All right.
How's it going, everybody? Thanks for tuning
Welcome,
in.
welcome.
I'm Philip Ong. I'm here with Dane DuPont, and we're going to give you guys our weekly Hawaii Volcanoes update today, December 17th, 2020. We're going to follow up on our update last week where we kind of were talking about the activity at Kilauea Summit, Dane, and we have some new news today, yeah?
Yeah, some new release from HBO and their Volcano Watch. Pretty cool.
Yeah, so without further ado, let's get into the Kilauea signals, right? We'll start with Kilauea since it's got the most activity, even though it's still at alert level green officially. We have more information on what actually happened on December 2nd with that injection of magma. So first, let's look at the signals and remind ourselves what actually happened. So here is our 1 month summit tilt. And you can see that on December 2nd, right in here, this big rise right here is when we're talking about the concern where we jumped about 15 microradians, showing the ground under Uikahuna, kind of under the Jagger or Overlook Museum area, shifting by that amount, right? That's this blue line, the green line being pool or crater. So that's what we're talking about, is that big offset of the ground. It was accompanied by a bunch of earthquakes. After the fact, we're able to see on the GPS that there is a little bit of a rise right in here, right? And since then, it's kind of slowed down, still rising, but at a slower pace than during those first few days of December.
Yeah, right after that signal, there was a jump as the intrusion happened. And a lot of the different GPS tilt meters that we're going to look at, there was also a bunch of seismic activity at the time, hyper focused around where the suspected intrusion took place. So one thing about the, like the tilt, just since maybe people can hear it in the background right now, is that it's absolutely dumping in Leilani, just raining, raining, raining. And we have seen before where, like the tilt meters are sensitive to rain, right? But this wasn't a rain signal. It wasn't raining. And that's a huge signal increase. What was it, like 15 microradians or something along those lines? I can't remember.
Yeah, that's right.
But huge increase in really quickly as the intrusion happened. So that was one of the interesting things about that tilt signal, right? Because tilt's weird. Tilt's been it's a fickle mistress where it can do things. Not every signal you see out of it is going to be a true signal, right?
Right.
And you see how they go offline too. There's all kinds of variables in these things. But when you start seeing it across the seismic and then later the GPS, all right, it starts to make a lot more sense that there's something actually, taking place, as opposed to just one tilt meter giving you one signal and it's the only one.
Right. Yeah, so we'll look at the signals here at the map that was released by the USGS here shortly. But yeah, just kind of point out while we're looking at the tilt, we do have at Pu'o'o this green line, these up and down variations every day, right? So that's kind of the kind of artifact you might have in signals. You have to know enough to distinguish that from these other up and downs, which are happening over 1 day or over 2 days or over 3 days. There are more of these longer deflation-inflation events connected to the magma chamber, the shallow magma chamber under Kilauea, being the actual volcanic signal. So yeah, it definitely gets complicated. And without getting to all those details, we can see that the magma chamber is still active, shallow on Kilauea. Maybe it adjusted a little bit after the fact with a little bit of a longer deflation-inflation event here, but it kind of, you can see that the deflation-inflation events are still continuing, ongoing. Not quite today, but recently. Yeah.
Yeah, and Pu'uo was offline because that happens.
Yeah, it's interesting. I mean, I was just kind of very briefly, it was offline kind of during right in here, and it kind of got offline again, and so they're definitely having some transmission issues with getting the data back, right? And I saw that in some of the other data streams as well. So there's probably just something happening, whether it's weather, whether it's the ground moving around and misaligning antennas that are communicating over long distances. That kind of thing is something that's kind of a constant challenge for the HVO network engineers.
Right.
So we want to talk about the Volcano Watch, and here's the title of it. The Volcano Watch is just published today. It'll be out in a paper and print on Sunday, but it's online already today. A small but notable magma intrusion at Kilauea Summit, right? And so we'll kind of go through the text in a little bit, but I want to kind of jump right to this map that was issued with it as well. And so this is a map of the 24 hours on December 2nd, 2020, right? And so what they've done here is they've used circles to indicate earthquakes, right? Bigger the circle, the bigger the earthquake. Up to magnitude 3 was the biggest event we had in that kind of sequence. And they've colored them with yellowish for early and dark for late, and kind of reddish is in the middle, right? So the early ones kind of happened more widespread across the whole summit region, but also kind of clustered underneath here. It's kind of a little bit hard to tell, but they're kind of clustered underneath there as well. And that in there is where they have, by their models, right? At the end of last week's update, Dana asked me, like, well, what are the scientists actually doing at this point to try to figure out what happened in there? And we talked about how they're probably inverting the INSAR data together with the GPS data, with all the tilt data, everything all together to try to figure out what size, what shape, what depth, amount of magma was actually injected underground, right? And the answer is this right here. So I might have to, let's see if I can zoom into this a little bit more right here. There it is, yeah. This green rectangle right in there is the area, the minimum area that had to have magma come into it. And so it looks like a flat rectangle, right? They kind of model this as like a sheet, and the sheet's actually tilted at an angle, right? So this north angle is actually pointing down, right? And the south angle is higher. So it's tilted inwards like that, right? And it's tilted inwards, they're not quite sure, between 40 and 70 degrees, I think was the range that I read. Right, but that more or less aligns with the edge of the caldera over here, right? This kind of whole, we talked about how when a whole caldera collapsed, all these cracks that formed on the edge over here were a likely place for magma to try to work its way back into once it did repressurize enough. And we talked about that 2 years ago, and here 2 years later, it seems like that actually happened. And it happened on that south caldera area near Kanakakoi. Kanakakoi crater is right over here. Right, yeah. So you can see the earthquakes were centered right kind of under that Silver Bank area that Dane pointed out last week, right, where the earthquakes were really drawing our eye. That's exactly the spot. Yeah. There were adjustments kind of all over the place, but certainly the cluster is happening right in there. Yeah. And also in here are shown in green arrows these GPS, right? So there's a station on the down drop block of the caldera floor right here. And it moved by, what is this, 4 inches? Yeah, 4 inches to the north. Sorry?
4 centimeters in about 4 hours, yeah.
4 centimeters in about 4 hours, yeah. That may be right. I may have to read the caption. Yeah, 4 centimeters right here. Yeah, right there. 4 centimeters. Yep, so.
Yeah, it's what we were saying at the time, like 2 years ago, a year and a half ago, about the edges of the collapse area, right, where these faults are, these circular faults around it, is that everywhere inside the caldera has turned into, with the collapse explosions or the summit collapse events, turned into a giant compactor that just pound the ground. Where's the easiest way up? Well, look where the crack is, right? And it's obvious where these cracks are, right? Because they form the rim of the caldera and things along those lines. So look there first, and that's where this thing came in. And it's, again, the one thing we were saying last week that they reaffirmed in this this update, Volcano Watch, was that we thought that this would be a small injection, right? Now, what is small, right? The kind of relative, but it wasn't a large event that interrupted the cycle, the DI cycle that Kīlauea was in, the magma chamber, then the gas pistoning going on. So we were thinking, okay, well, small, especially with the amount of earthquakes, you couldn't get 1,000 more earthquakes easily in 24 hours on a big one, on a big injection. So we're thinking, small kind injection, and now they're saying that, yeah, it was a small one, but they went much further and gave you examples because they were able to calculate it. They're saying basically it's like the amount of magma that Fissure 8 erupted, and during the 2018 eruption, the amount of magma Fissure 8 erupted in an hour to 2 hours, right? Fissure 8 was variable, especially midway to the end, but in an hour and 2 hours, that's basically the volume that was injected into this area, right? That they're showing in that model. And then again, however it's small, it's an still a potential clue for future behavior. And that, we'll get into potential future behavior. But the interesting thing they then go into is how many other times that these types of injections have happened in the range that they happen in, right? They talk about the 1974 and several more recent ones that have taken place where they range in scale. Some of them are much bigger and even involve, actual eruption, whereas some are more along these lines, but just more volume. And this one is, as they say, there was one in 2015. This one was 10 to 30 times less magma than that one.
That's right. Yeah, in 2015, that was when the lava lake first overflowed at Hawaiʻi Mauna, right? So there was a lot of pressure, enough that the lava was pouring out the top, flowing out onto the crater floor. And yeah, it was also erupting at Pu'o'o at the same time. And so even at that point in time, that excess pressure was enough to inject up to 30 times more magma than we saw this month, right? And it did not cause any further activity, unlike 2018 when the lava lake also overflowed, and it led to the whole change of Pu'o'o, and it led to the whole low eruption and everything else, right? So we're way back, we're several gears behind, down from there still, right?
Right. In the process of recharging everything, getting that shallow accumulation of magma, getting the system all primed up and ready to go, something big again. It takes a while, the cycles.
Right. So if the pressure, the amount of magma that was able to get injected from the pressure was that much less, then kind of the most obvious thing to think is, well, the rock, the whole area as a whole, it's weaker, that smaller pressure could now actually inject into there, right? Rather than before where you might have been able to hold it in more to build a higher pressure to cause something else to happen, like an eruption farther down the rift zone or something like that, for example. Whereas now we just can't even get there because the summit is so weak. It's injecting under that fracture zone first and foremost, as was expected from the very first day after the eruption was over, right?
Right. Significant part of that shallow magma chamber has been changed by the 2018 collapses. The flow up, especially the conduit from there to the surface and the top half of that the shallow chamber, because we were seeing that only like a third of the volume potential, or the estimated potential volume of the shallow chamber was erupted in 2018, whereas we're more at the time, but it's still, that compromises things at the top, especially with how deep that collapse went, right, and how shallow that chamber was. So we've changed it up a little bit, and now it's kind of remaking itself, it seems, in some ways. And the top of that chamber, trying to figure out what it wants to do. And it doesn't have a crazy amount of pressure behind it, because it didn't go into a runaway sequence where it led to an eruption. It just did a little injection, and then back to more normal vibes that we've been seeing over previous weeks before the injection. Right after the eruption.
Right. Yeah, so it's interesting. Yeah, they do mention in their text here, they do bring up 1974, because there actually wasn't not only an intrusion, but it actually proceeded all the way to the surface, which makes it an eruption. That's the only difference between these intrusions and eruptions, as magma makes it to the surface and comes out as lava, right? That's basically the same process, no matter what. So it was an almost eruption at the summit. It doesn't, not that it was going to make it to the surface, because it was so cracked underground that it didn't have to go that far to relieve itself, right? As Dane just said. But the fact that they're considering, the fact that there could be an eruption happening, to the point where they actually talk about in 74, the activity they mentioned here, the scenario was in the minds of HVO scientists as the events of December 2nd unfolded, and an overnight watch was established to closely monitor data feeds. So it was important enough for them to actually establish an overnight watch, right? And of course, that's why, we were also trying to provide timely information as that was happening. So you can see that there was clearly a risk of lava making it to the surface and erupting at that point in time, even though it didn't actually happen. It was something that was considered. Right,
and it kind of goes into one other thing that is not mentioned in there, that the justification for the remaining at green normal advisory level on Kilauea. Right, that was one of the things we were kind of suspecting was going to be more into this one, and it seems like this is the reason that their justification for keeping it at green. But it seemed like at points that it didn't look like it was so green. It was, the shade of green looked mighty yellowish, one might say.
Right. Right.
It might have gone back to a shade of green, but there's just some questions around what is yellow going to mean when it does come, right? We don't want to skip yellow and go straight to orange. So what is yellow?
Right.
Right. We have 4 levels. We're at level 1. Level 4 is an eruption. We still got to parse out these other 2, especially the green to yellow transition. That's kind of the one that we keep harping on because, hey, we're setting precedent now, and we don't want to do a backdated precedent where we wait for it to erupt and be like, oh, okay, well that's where now we're going to make the cutoff for next time, right? On where we draw the line between green and yellow type of thing. So
right.
That's just my layman's outside perspective on looking at it, kind of.
Yeah, well, it's interesting to talk about that because I mean, there were times when Pu'u was actually erupting and in a state of yellow, actually, right? But it was doing that not near any people, no one's residence, no one. It was just kind of in the middle of nowhere. So there is a little bit of a factor of like, how close people are to it also. So clearly when it opened up in Leilani, it was immediately a red because not only is it erupting, it's in the middle of people. And so you automatically are red, right? But, there could also be an orange or a yellow version what actually is erupting at that stage. And maybe they're considering it that way, right? And this is an area that it's hard to put, the park has trails open near there, right? But maybe there's not as much vegetation in the park and it was easier to close the trail. Maybe there's just not as much of a risk to humans, and that's part of the consideration as well, right? So that's just something to bring up. That could be part,
Yeah, probably is. My question would then be, doesn't this same volcano watch also mention a potential for explosive eruptions upon magma returning to the water lake? Or was that somewhere else?
What it does say, yeah,
so it's like, okay, so if we're talking about that being on the table, right? Either we're saying that that's going to be really small, or in order to justify that continued green, when we can't remove that from the table. We tried to remove that explosive eruption from the table. It can't come off until the lake is gone, basically. Might be low probability, but it's still there.
Right.
And if we had basically the amount of volume that we saw in Fissure 8 happen in 1 to 2 hours, happen in a course of around 4 hours, most of it, right? That's that's pretty quick. It's not dangerously quick, but that's pretty quick for the initial tremor, maybe the first life coming back to Kilauea. Like, all right, what's the timeline look like for the next iteration of this? And then do they become closer, or do we get just one and done and big break? There's a lot of questions there, because one of the things we'll get into is the movement on the GPS a little bit that's happened after the December 2nd earthquakes, right? And how the little bit trend changing.
Right. Yeah, so let's go back to the map here real quick, and just kind of finish this thing off, right, as we kind of figure out what was happening under our volcano. But yeah, I mean the points there, we can kind of probably could talk about this forever, this yellow and versus green thing, and we'll keep commenting as it happens or doesn't happen as the weeks go by, right? And so we'll learn essentially how they're judging it by how they play the hand here. There's the station we were looking at on our update was this one over here at Uekahuna, right next to the Jagger Museum. This kind of green arrow right over here. But the one that showed most of this movement was over here, actually. And I was looking at the scale again. The scale, 4 centimeters is this long, and so our arrow might be, I don't know, maybe 1.5 times that long. So it might be about 6 centimeters, something like that. So it might have been 3 inches. I don't know. It's somewhere in that range, in that ballpark. There's other green arrows on here. There's one over here, Byron's Ledge, right? It moved not nearly as much, right? There's one over here who will move not nearly as much, right? Over here. This one over here might be the outlet or near outlet station. That one barely moved as well. Right, so it kind of was very localized, this event. Yeah. And so maybe let's look at the 2-year GPS now. And so here we have 2-year GPS at Uekahuna. which is that station by the Jagger, right? And so here at the right end of it, we can see, I'll draw it for you guys can see a little bit better, right? The trend was going down, and then it kind of got quite a lot steeper. And then here at the end, it's fuzzy, can't quite see what's happening. Not quite so clear. If you look at the north, it clearly jumped up and is more stable now. So that part seems to resume, but whatever's happening in the east seems to be ongoing. And the trend that was happening in the up was kind of happening beforehand. That hasn't really changed at all at Kahuna. Right? So looking at Byron's Ledge, that's the station over at the east, right? You can kind of see there was an adjustment up and over and on the east, but likewise the north and the up haven't really changed their trends that much since the event happened.
Little up, maybe.
Maybe so, yeah.
Yeah.
Yeah. Here in the outlet, that's that one on the southwest of that map. You can kind of see we're still moving a little bit faster than we were beforehand over there. Even though the up is kind of the pattern of up has been going on steady for a while, and not quite as clear as happening here with the east. So for the rim, we don't see it quite as much. If we look at the east, I'm just going to scan the east rift, Mauna Ulu. Not a whole lot of change there, really. Not really seeing a whole lot of change happening right there.
Yeah.
Kind of Nui Ohamo, there's some wiggle, but like it doesn't really correspond, and nothing really happening there. So really, it's not on the East Rift. I'm gonna scrub down past all these East Rift stations, and we'll just note here for the record that Jonica is showing data back online now. So, but it's also
since it went down, it's kind of just been a cruising.
You can kind of guess what those trends are in there, something like that. Now, if we look at the South Flank stations, this one's a Hua. This is a kind of, it's borderline the South Caldera and borderline the north part of the South Flank. It's kind of in that in-between triangle zone right in there, right? But if we look at this signal, the north signal, it's been moving to the south. It's always been doing that for a long time. Going south, a little faster, a little slower, a little faster. And then the event happens here at the end, and it's going really fast. And that hasn't changed at all ever since that. The last 2 weeks, it's been the same, right? So
you also have the vertical looking kind of. The trend is one that started previous to even October, let alone December.
Right.
But there's some vertical action going on with that one as well.
Yeah, that could well be the signs of magma pressurizing to prepare for that injection to happen, kind of back from October already.
Right. Setting the stage for pressurization to happen at the around the caldera. Right.
A little further south, same thing. Kind of just it's not as big, but a slight increase right there. And same pattern on the up. Devil's Throat. It's kind of partway down the Chain Critters Road near the rift zone, and a little bit of a increase happening there as well. Kind of looks like that. Yeah. So you guys can see that. No, that station isn't there, and now we're back by the rift zone over on the east side, right? So that's basically it, right? That's where we see the activity showing is just in those locations, right? And here's our summit tilt distance once again, right? Showing a little bit different, right? The event happening fast, and then kind of since then continuing to inflate, but at a slower rate that happened during that 1 day period, right? Kind of surrounding the first few days surrounding the event. So that's interesting. Moving on to the East Rift here, you can see that the distance from North Pu'o to South Pu'o hasn't changed, and all the caveats that go into all the variables that are there. It's kind of amazing that it hasn't changed. So it's definitely stabilized quite a bit. Maybe everything is quieted down enough. That seems to be stable over there until we see something else that'll mean something more significant now. Right now we have a reset.
Or is Pu'o in that area so volatile that you have net offsetting changes, so it's a net zero basically happening, because that place is very volatile. Yeah. So for it to be quiet and not moving, it's like, all right, so what's moving?
Yeah, possibly it's it's canceling itself out. Yeah, but a little less likely right now. I'm just going to believe it's there's no earthquakes kind of past there as well, as we'll see here shortly. So that's another thing we can talk about, right? Yeah. Looking at just the rates of earthquakes, this is just Kīlauea now. Over the last year, you can see that the last couple of weeks have been higher, right? That was kind of corresponds to the intrusion, and we actually had in October that kind of flurry of earthquakes also, right, under the summit. And that's kind of interestingly when we saw that pattern, and we just talked about in a 2-year GPS, right, that kind of sped up, going and going south. That kind of began in October. That's that first flurry of earthquakes that we had, right? Kind of. Although this also includes the Kawiki adjustment, right? That happened.
That
with Mauna Loa as well, right? So the kind of combined thing in there, right? It's really been since June we saw the first warnings from USGS that there was increased activity of earthquakes, or the summit in particular. And before that, it was more flank earthquakes, as we talked about last week.
Right.
Looking a little more closely at the 1 month scale, you can kind of see that just in the last few days, it's been, average, right? Earthquakes continue, but it was really that spike on December 2nd that was the intrusion.
Right. You can see the difference between it and just a normal day. It's kind of stands out a little bit.
Right. And you can see that was a shallow intrusion from the shallow chamber. On this kind of depth plot, we see right down here, really, the scale right here is 10 kilometers. So all this stuff was happening, on the second right, in this upper part right in here, just hidden in all this noise. You couldn't really tell from this particular information that was something happening there.
Go back up just a touch to that same one.
Yep.
That you're on. Yeah. So that bar graph, the December 2nd, on an eruption or like a big intrusion, like what was it, the 74 intrusion?
Mm-hmm.
You would expect to see that spike to be so tall that it make all the other ones, the scale would make it look flat, and then just one big bump, because it would be thousands in a day,
right?
As opposed to 100 for the small thing that took a few hours and then settled back down.
Right. So this line, just to read you guys over here, this number says 250 earthquakes on that day is what they've measured on this plot.
Yeah.
After all is said and done. Anything else here, Dane?
Nope, that's all.
All right, I'm going to scroll down to the plot of over the last month, all of the earthquakes on the plot here. So this is there's a lot happening here because it's a whole month. So we have the events we talked about last week, the deep earthquakes, and blues over here. We talked about the south flank cluster over here, right? We talked about the summit activity with a southwest rift and a southeast rift kind of flare-outs over here, right? You can kind of see there's some activity happening over here kind of between Mauna Ulu and Pu'o'o as well in this upper east rift, right, on this 1 month plot.
Yeah.
Let's go to 1 week. Just the last week, you can kind of see that not so much happening in the zone, Middle East rift zone so much here. It's almost all happening on this upper east rift zone, upper southwest rift zone, and the Caldera region right in here. Right. Still some Pahala earthquakes happening down in the south, and kind of sparse, smaller south flank earthquakes happening all through here. And a few over here in the east part. But overall, the same pattern we've been seeing the last 2 weeks, yeah. So, but it is showing kind of, that there is magma still filling the summit. It's still filling the summit. It's still kind of vibrating the walls of what's become basically a big magma storage area. That's the whole Caldera region, including the upper east rift zone and the upper southwest rift zone. Right through there, right? That's what we're looking at. And enough to pressurize it, pop open that little thing. So let's look at the gas and the water. There's not a whole lot to show you guys here. Our 1 month plot of SO2. We thought maybe we might have seen a little dip and change in the baseline, but you really can't really tell well enough anything here. And then, obviously the spikes are possibly important as well, but you really can't see anything obvious happening in here. This plot on the bottom, I suspect this is one station we saw offline a couple weeks ago. This may well be some kind of calibration. This is not something that we can kind of, on its own belief, since we don't see it anywhere else, right?
Yeah. That thing, I don't know what that thing is.
Yeah. And it may have to be...
And then they dropped it, it turned on one day, gave one readout, that was it.
Right.
I don't know what is going on with that graph.
Yeah. Well, sometimes to calibrate an instrument, you allow it to sniff a sample of known concentration, right? So your known concentration might have been 55 ppm, and the thing sniffed it, and there you go, 55 ppm.
It was like, is this thing on? Give it a smelling salt.
Right. So that's kind of, yeah.
Yeah, it's on. Okay.
So it could have been, that seems a more likely explanation than anything else. Just because if you look, at the same date and time right here, you don't see anything. Right, and it seems unusual you'd have that much gas in one place and not somewhere else nearby. Right, so yeah, but we can ignore that. But that's just part of the process of looking at the data. And then the last thing we'll look at here is the water depth right? And the water depth, it's kind of hard to see. I don't think I can zoom in any more than this, but we have one new point over here on the right, and it's right around 50 meters. So it went up slightly, maybe 1 meter. That's the kind of range we're talking about. It's kind of a slow rise, right? And we've done some calculations, and we kind of, based on the rate of this thing filling and the size of the cone it's filling into, like that's about what we should expect, about normal, going forward, is this kind of slower rate of 1 meter, maybe 2 meters rising every month, as opposed to if you look back to the whole last year, we've gained about 30 meters, right? Almost 100 feet. So it's slowed down quite a lot. You can kind of keep filling at the same rate, but not rise a level nearly as fast because it's rising wider and wider and wider, right? So if it stops rising 1 meter per month, if it stays at 0 meters a month and a 0 the next month, and then we can start talking, okay, are we within a range of measurement error, or what's going on here?
It kind of looked like it was going to try and do that. But then we got this last little dot, the last data point. And it's like, never mind, we're going back up again. Just little bits now.
Yeah.
But we're going back up a little bit.
Yeah, and there have been slight slowdowns, some short slowdowns where it seemed like it maybe wasn't rising as fast, or it might have gone down from one day to the next. So, we're not sure, if that's measurement error, if there's like some local variation in the water one day to the next. That seems unlikely, right? So that kind of gives us a little bit of a ballpark kind of overall of how this goes. So it's still filling down there. Not much has changed apart from it's filling a lot slower. Is the bottom line there. Yeah, anything else, Dan, in the water?
Nope, still there, still brown, still circulating around. Not much change on that. Still can't see it from anywhere that you have access to in the park.
Right.
All those things remain true. They're still doing drone flights every, like month or two up there to get samples. And since we're not hearing anything back from those other than, the occasional mention that they're still going on, I assume that there's really nothing that much that's changed over the time that they've been doing the drone flights into it. They're kind of just, establishing a baseline and it hasn't deviated from that really. Sure, if there was, something really notable, it would make it into a volcano watch of some kind if it was interesting, but...
Right. If there was some signal that would tip us off, yeah. I mean, I think there have been some challenges with COVID as far as how much they can sample. There have been some challenges with the drone policy of the U.S. government as well, right? And then not only that, they have to collaborate with the National Park Service, which, we now have a new superintendent, and that's more stable now as well. But that was also going through transition as well. So there's a lot of other factors that, wrenches that could get thrown into gears there, right? So, I mean, I think if you were to ask them, they'd say, we absolutely would love to have another sample as soon as possible. But then how do you make that actually happen, right?
Right. I mean, 2020, I mean, at this point, you can have a drone that you program to do an auto flight daily. It's, program basically to do the routine, know exactly how far to go down and where to hit the GPS point, and but with the regulations that they do face up there, that makes it hard, right? If it was just left up to innovative people that have drones, then there'd be all kinds of drone flying going on, but they're like really hesitant about crashing a drone, so they're taking their time and doing the proper channels and all those types of things.
Right. So yeah, I mean, is there anything else you want to say? I mean, is this volcano, like, looking at the water, like looking at gas, there's no gas coming out, maybe because it's going in the water, but like, there's not that much sign of activity otherwise, apart from the earthquakes that happened last week. Should it be a green still, Dane? What's your final word?
Just put it at yellow. Put it at yellow for no other reason than I want a weekly update on Kīlauea. Right, as they go from monthly to weeklies at that point. So yeah, just kick it to yellow because I want the weeklies. There's enough interesting stuff happening that just keep a tab on it. Shouldn't be waiting a month for updates on it.
Right.
Something could change pretty quick week to week. It seems like it's a monthly release schedule is not going to be adequate at this point. Maybe it was a year ago, but yeah, it was a year ago because not much was going on. But now we've had a few special releases about this, intrusion and volcano watch. It's like, guys, just, bite the bullet and start doing weekly releases again. And if you got to bump it to yellow to make that happen, then you have enough justification to do so.
Right.
That'd be my argument. At the end of the day, more information, the better for the people that, live on the island.
Right. Well, as everyone knows, it's not up to us. We're just talking hot air here, but that's what we believe, right?
Yeah, that's just an argument.
Yeah, we'd definitely like to have more information, and that's our premise, of course, and that's why we share information with you guys every week. At least, especially when things are happening, changing this much, and they're this exciting for us to talk about, right? So
Yeah.
let's transition now, and we're gonna move over towards island seismicity. We're gonna look at Mauna Loa in particular here. I know my screen's...
There's a question: is the lake temperature of the lake staying the same? That was the one thing I forgot to say. The temperature on the lake is pretty much the same, as far as we can tell, without going to in depth diving into the temperature scales of the infrared camera or the thermal camera up there. It's basically the same.
Yeah, there's been no report and change, nothing that we've seen. We had one of our colleagues today pointed out to us that there could easily be satellite studies of this as well, monitoring of temperature happening as well. So we hope that that's happening behind the scenes, and if anywhere in the world does that analysis and finds something, you can guarantee we'll hear about it, right? Because it's too exciting not to talk about. So no change really is what the
It's so exciting on Kilauea that you can have 4 centimeters of change in 4 hours, and that's not even a big deal.
Right.
It's just stirring. Don't worry about it.
Yeah. Any more questions about Kilauea that you can see, Dane?
Yeah. Let's go to Mauna Loa.
All right. So we're looking at the earthquake map here, and you can see our earthquake patterns. Right. We actually had that earthquake on Mauna Kea earlier in the week, which was a kind of a settling adjustment earthquake. It was really deep. Yeah, a couple of aftershocks in there, right? 12 miles, 15 miles down on that one, right? Kilauea earthquakes we talked about right in here. These are the Pahala deep earthquakes over here, so not much new there. What we're really interested in now is kind of zooming into these ones over here on Mauna Loa. And of these ones in Mauna Loa, there's a 3.1, there's a 2.3 in there. There's some bigger ones in there, right? But they're kind of all in this cluster, in this area that's kind of northwest of the summit Mokuaweo'aweo crater being right over here. Right. So that's kind of the placement of it. Let's kind of go to the earthquake rates now. And here is the last 1 week, right? So, and by the way, all this information that we're showing you guys is all USGS information. So even if they don't actually put out a written update, every week, then information is coming out, new maps daily all the time, right? And that's kind of the basis. Everything we're showing you guys is all USGS data, just to make that clear. So last week here, automatic USGS map showing that cluster of earthquakes and all the small aftershocks here northwest of the summit. Not much happening under the caldera, which is interesting, right? We've had periods in the past where we saw a lot of activity under the caldera and this little flare up in the northwest, and even a southern spot over here, right? And right now it's just this northwestern spot.
Right.
Yeah, Dane?
That spot is just as we've said before, that's a weird little spot. It basically has the seismic activity of the summit in terms of frequency, maybe a little less, but it's up there compared to anywhere else on Mauna Loa, right? Mm-hmm. There's the big three. There's the north-south of the caldera, and then this little spot to the northwest. And this little spot, just since since 2015, like 5 years ago, we had one of these flurries, just like we're kind of seeing now in August 2015, another in July 2016, one in April 2017, another October 2018, right? So that area can just turn on, quake for a little while. They can even be shallow quakes, but not everything is as they seem in that little spot. There's some other mechanisms at play that make it a little more complicated than, say, the summit at large, right? The summit makes sense, you see the inflation, but this little spot is a little bit different.
Right. Yeah, here's the last month. So kind of see a little bit more over the last month. It's kind of all still been in that same area in the northwest. Some kind of background earthquakes happening all around the rest of Mauna Loa, right? Even this one very deep one under the summit caldera. But really not that much happening with the summit over here, right? Here's our monthly rates here, so you can kind of see that it's been a little bit higher in the last day, a couple days ago, but really it doesn't compare to as much as happened earlier in the beginning of the month, and that's just little spikes. I'm gonna scroll down further so you guys can see the 1 year plot of earthquake rates. So here we are. It might be a little high compared to the previous months like we just saw right over here, right? Especially considering the dip in November, right? That kind of followed that October flurry at Kīlauea, right? That kind of changed everything in Mauna Loa. This is like the key time moment for us where I'm talking about Mauna Loa where everything changes for us here. This is October, this past October, a couple months ago. And compared to the rate of the whole past year, we're not as high as we were several other times earlier in the year, right? And
Right.
we zoom out even more to the 5-year plot, and here we are, right? We're kind of in that zone. It's kind of still elevated post 2018 eruption, right? But still in a very up and down pattern, right? All through here. So that's what matters. It's not steady high. It's up and down.
Right. Fluctuations going on, but the interesting part really comes with the GPS up there and the trend change that happened in the October.
Yeah, so here's a GPS. You gonna talk about it, Dane?
Right, so we just kind of had that earthquake swarm, and then from there we started to see the GPS. This one's showing the distance between more the west and east end of the caldera, maybe northwest, southeast of the caldera on Mauna Loa, and the distance between them. And it was steady inflating, steady growing, steady getting wider. And then something happened, right? And it dropped. They, got closer together, and then it's been stable since, basically. So that's like really and it stands out from many of the other things. You can see previous trend changes on the summit of Mauna Loa, but they are not that large, right? There was, the big one that comes to mind. What was that? 2014, 2015.
Right.
Say that when it had a big change there, and we kind of bumped up the advisory level a little bit. But this is again like an interesting change. What does it mean? We don't know yet. We still got these earthquakes going on in that little funky location, so it's not like it's completely quiet up there. Like everything dropped off, but something changed.
Right. Yeah, and what's interesting to me is you can kind of see that before this event, before the October Kīlauea sequence, we were actually inflating the summit, and now we are in a different trend, right? So you'd expect that to pick back up and at some point resume inflating, right? And so it's maybe a bigger bowl shape. We'll have to see how it actually turns out here, but this is kind of an unfinished story, still in progress, still developing. There's more has to happen over here at the right end of this graph to for the story to come to its end. Yeah. So that's kind of the pattern of that, right? And interesting, comparing it to 2014-15, this is actually an opposite direction, right? So it's like more of a slowdown rather than a speed up, right? Right. But it's still interesting, right? Because it follows a Kīlauea earthquake, so clearly the volcano is adjusted, and probably in response to Kīlauea. When a Kīlauea event happened, we speculated that was likely the result of Kīlauea inflating and putting pressure on Mauna Loa enough to actually pop that, right? And evidence just been gathering every week ever since then that Kīlauea has been inflating more and more and more, and eventually a couple weeks ago we saw that little intrusion, right? So that seems to all still fit. The story is all fitting together as we expect it to.
Right. We've known that they play on each other, right? Predicting how one will play on the other and what impact it will have is the hard part, but they do play on each other, and we've seen that over and over again. Especially, even just the case in point was 2018 eruption. The relief of the evacuation of magma from Kīlauea rapidly down rift allowed Mauna Loa space to breathe, so it kind of stopped inflating. Right? We lowered it to green advisory, and we kind of just cruised for a little while. Then after 2018 eruption ended, all right, time to pick back up and do what we were doing before on Mauna Loa. That's what the GPS was basically doing. So we just continue to see them play with each other.
Yeah. That's fascinating.
Yeah.
So to kind of look into this effect a little bit more, we also are looking at the 2-year GPS on Mauna Loa. So this is on the southeast flank near the Ainapo trailhead. The trail up at 12,570 feet. Right, that's the easiest way to kind of keep track of these things. And so you can kind of see that after the October Kīlauea event, we've no longer been moving to the east. We're kind of very slowly slouching west, even though it's mostly stable, right? But it's definitely not moving east anymore. The north, we're moving slightly north instead of moving to the south prior to that, right? These trend lines haven't changed, right?
Like, see the trend on that south, it didn't really deviate. Was this a 2-year GPS?
2-year GPS, yeah.
So for the past 2 years up until October, that was pretty stable in terms of the rate and the trend.
Absolutely.
And then this October happened and boom, instant change. And it hasn't even gone back. Like wasn't just a blip. We've still on a trend change since October, since this thing we've been holding.
Right,
so that's one of the things there.
Yeah, exactly. And something else has to happen for the story to kind of complete still. It's, it still hasn't resumed trend or done anything from a new trend, right? So that one, yeah, the next station down at 12,140 feet elevation. Over here, right? Same thing. October, and there's our trend change right there. It's showing in the east. This one is not showing so much in the north, right? It's kind of hidden in there, not showing so much in the right? So not quite as big an effect, right? Already at 12,140 feet, right? Although clearly on the east, very noticeable effect. Now we get down to the sleeping cave station at 10,300 feet elevation, right? There's a lot of scatter in here. I'm not sure if this is, just from, this is real scatter, or if it's, noise in the data from COVID, lack of maintenance, or those kind of things, right? It's hard to really tell what's actually happening here. But let's just kind of give it the benefit of the doubt for now and say that that's, on average, kind of stay the same. Didn't really change there, right? And we look, didn't really change there. Or there. Right, so this effect is not visible at the 10,300 foot elevation. Right, it is visible 12,000 feet and higher. Right, so very localized to the summit of Mauna Loa. If we kind of go back to the map here, right? Right, we're talking about it's localized 12,000. It's really like something just in that upper summit area, right? Not really coming down a mountain that much.
And one of the things Phil was mentioning before we went live was how, the potential for something falling between the net of monitoring, right? And some event happening. And when you think about Kīlauea, we have all these stations. We were just showing all the GPS stations and their movement just at the caldera itself, right? But that continues on the East Rift, and there's all kinds of, monitoring all around. It's the most monitored volcano. But then in Mauna Loa, like before 2019, it was pretty scattered monitoring. And then the USGS decided, hey, let's get some monitoring equipment up there, bolster it up a little bit. But it's a big volcano, that one, right? It's a lot of distance you're covering, a lot of difficulty in accessing areas, right? You don't really have a clear road, right, going around the caldera like you do Hawaiʻi. But it's a little harder to get to. It's bigger, so it's harder to have every instrument in the right place exactly. But they're trying. They got a network up there of multimeter monitoring for SO2. Sorry.
Yeah.
Dog heard the rain and thought somebody was driving up.
Yeah, tilt meters. Here, I'll turn on, right? There's earthquakes, there's tilt meters, there's 4 in an area. Seismometers, there's quite a few. Couple of gas stations. Quite a few GPS stations. And some camera stations.
The GPS stations that are listed and the GPS stations that actually are online.
Yeah. So, yeah, those stations exist. We're not card-carrying members. We're not allowed to see them, right? Because they haven't been posted to the public part of the website. But the data streams exist. So the instruments are in the ground, like they're actually measuring stuff. We just don't get to see it. Just like the instrument that was on the caldera floor last week that showed that 4 to 6 centimeters of offset. That instrument we don't have access to either. So there's quite a lot. If you look at the network of instruments, they're not showing publicly, but what really matters in the end is that they're actually operating in a back end. We would love for them to all be fixed so we can see everything on the public facing side as well. But that's not where we are now. We're still on a catch-up phase as far as that goes. So anything else on Mauna Loa, Dane?
No, I'm it's back to raining pretty hard out there. 1 second.
All right. Well, so the last thing I was gonna discuss with you guys today, kind of to bring our broadcast to a close here, is just to discuss a little bit more of the current research that's happening since 2018 eruption on Kīlauea. The AGU conference, American Geophysical Union fall conference, is just wrapping up this week, and there's been all kinds of presentations happening on science that's being done, research that's being done on the volcano. We talked about that a little bit last week with the gravity as one example of that, right? We'll have more stories coming over the next few months, and I kind of want to give you guys a little broad level overview of the kind of things that are being studied in Kīlauea, the kind of things that are ongoing here, right? So we talked about the gravity a little bit already. There's been quite a lot of measurements of gas, right? That, there was a lot of they took all the gas equipment they have and took it down to fissure 8 during eruption and pointed it at it and got all kinds of results. And so that's fascinating. We can talk about that at some point, how the measurements vary, what they use to measure them, all those kind of things. So gas is something in the toolkit right now for sure. The gravity we talked about not only detected the signals of the ground opening and magma coming through, but also can detect changes in the density of the magma, which is hugely interesting, right? To tell how it actually can change density going from the summit to the rift zone, which kind of is an interesting nugget for later discussions. All the olivine crystals we've just talked about, for years with you guys, how you can extract information from how the actual molecules crystallize within the atoms, or I'm sorry, within a crystal. I'm sorry, the molecules in the crystals crystallize and bond together, right? The atomic structure is something that, and the isotopic composition is something that varies depending on the magma composition, which varies in a pressure and temperature. So bottom line, if the crystal comes from deeper, it shows a different signature than it comes from shallow, right? And kind of can tell by looking at the right part of the crystals and all that, like the path of the crystal through the magma until it come out of the ground where you can collect it. So there's all kinds of studies on that, right? Which are interesting. They can even go in and try to measure the CO2 content in the magma by measuring what's trapped in the bubbles, in the lava, in the olivine, and after the fact, which is really kind of mind-blowing. But we'll leave the full detailed story as a teaser for another day. There's all kinds of work happening as far as assessing the damage, right? Like gathering a database of all the damage so that can be a baseline for future eruptions, because believe it or not, this hasn't been quantified that well before in other places, right? Especially basaltic lava flow eruptions impacting people's houses, less so than ash falls or other things like that. There's scientists studying sound, right? Infrasound that can detect pressure waves, whether they're sonic from the magma gurgling out at different dynamics, whether it's with more gas or less gas or more pressure. Those kind of things are still being worked out because infrasound is such a new technique. They're really kind of honing in on all the signals they saw and tying it to all the events they saw as well. So that's really another fascinating thing to dive into at some point. How you might be able to tell different shapes and what's driving the sound, which nozzle is vibrating to cause those kind of frequencies, right? So that's a whole other can of worms looking at the infrasound. Right. We've looked at tilt quite a lot. Tilt's kind of been, like a go-to, albeit, complicated monitoring technique. Something we've been going to for a long time, right? But now we're getting so refined that we can use that to input into our models, like we saw with the injection of magma we presented today, right? That's been used for other modeling as well in the past, right? And so one kind of teaser is that tilt seems to indicate that the connection to the east rift zone from the summit is actually fairly shallow. They believe the tilt is actually showing a upper summit magma chamber to the east rift zone connection rather than a deep chamber connection. So we'll have to dig into that later and see, how true that might actually be. GPS, right, has been input into all these studies along with the INSAR and the tilt, kind of the same kind of thing, right? And GPS is getting more useful because it's been going on now for 15 years, right? GPS, we don't, it's something that now we take it for granted almost, but 20 years ago, we didn't have access to the satellite data. And so the data record, like on volcanoes, the longer the continuous record you have, the better the data, the more you can learn from it. And now we've been running for a while now that we stop and take a moment to look back, 15 years, right, of GPS data is quite a bit to build on. And so that's a more and more useful database as time goes on, right? LiDAR, right? We've shown you guys some of the LiDAR results, the DMs of the fissures, those kind of things. Those are also super important when you're trying to figure out, for example, the volume of the lake inside Hawaiʻi Mauna Loa. You'd like to have a DEM LiDAR scan of the thing to be able to tell exactly where all the rocks are sitting, exactly how much space is in there, rather than having to guess and approximate. That's so LiDAR is super important, right? Earthquakes, like there's a lot more to earthquakes than just where they happened, how deep, and how big. That's like just the first pass of what an earthquake can tell you. You could also measure like how fast it's moving through the ground and whether it's moving faster or slower through the ground than before, which can tell you the ground is more or less stressed from magma pressure or from the magma itself, changing the travel properties of the energy before it reaches the seismic station. That's kind of one interesting thing. One thing that came out is that they actually deployed ocean bottom seismometers during this eruption. They didn't make it out here until June, right? But they actually started to deploy. It's hard to get on maybe might have been beginning of July. Get all your gear on a ship and then get the ship to cruise out to the spot, deploy the things, and then you're deploying them in a huge depth of water. So they don't always work. So more on that in the future as well. But, they actually were ocean bottom seismometers deployed during this eruption. We have about a month of data from that. They also have what they call a nodal array, right? We actually have little seismometers, or like this, like a can, like a coffee can, like this big, with a big stake in the bottom. You can just shove it in the ground anywhere, and that's it. And you just put them all over the place, and that gives you more information. When you have that many earthquakes happening, it can give you more, like it can expand your network for a short time, right? So that's another study which we'll discuss as well. Oh, excuse me.
I challenge you to jam a stake anywhere in the ground in Puna and make it actually stick. Easier just to concrete it to a rock.
Yeah, it's interesting. We'll have to see how the results pan out, but they're designed to kind of be wiggly in a sense, right? Like it's about having a spacing between them that's small enough is mostly the key to it. Because if that's the case, you can kind of correct for a lot of things. So if you have them like every 100 meters down a road, and you have 20 of them, right now it's like a giant antenna rather than well, if this one over here is wiggling and that one, well, that might not matter so much.
Right.
So it's similar as a lot of astronomy. It's data signal processing. It's kind of you can kind of borrow this some more techniques, right? But anyways. There's a lot more to earthquakes than just where they are and how big they are and how deep they are. And maybe I'll leave it at that, because there's a lot more you can tell with earthquakes from that, right? Viscosity of the magma, the stress directions, which way the ground is stressed at any point in time. So that tells you which way a crack is likely to open up, if it's going to open up, which direction it might be, those kind of things. It turns out that if you monitor that in real time, you can actually tell that an intrusion is likely to happen in a short term. Turns out that was something they saw at Pu'o'o, was they actually saw the stress field rotate 90 degrees before the dike popped up and through. So that's a big giveaway. Right. Whoa. Something clearly changed the forces right here, right? And what could flip the forces like that? Has to be another force from below pushing, changing all the axes, something like that, right? So INSAR is
it's about how to turn all these technologies that are somewhat emerging still, and how to take it so it's like, oh, we saw this, during the eruption, and we processed it, like a year later, then we published it the year after that, to real-time monitoring networks, right? The papers for them now are there, right? The basis for maybe trying to get the grant to do it with, right? But a lot of these things still aren't there yet. That's why we're still looking at the things we're looking at. Right. Absolutely. Yeah. And in fact, one of the things discussed at the conference as well is like the future direction of the volcano observatories, right? And they do expect to have a lot more data processing and a lot more automated alarms, and based on a lot of these kind of techniques and processes that we're talking about as well, right? So that's a big part of it as well, as programming all this stuff to make it automatic, right? And something that's just always there when you need it, rather than something you have to do extra while something else is going on, right? Which is the research and development phase, right, of any kind of new technique. That's how you go about it, right? And one last thing I'll mention is that there are people from other places in the world, like Iceland, that have talked about their own caldera collapses and how they relate to ours and how those things are similar. So there's a lot to learn there as well. And we at some point in the future will also discuss parallels between Hawaii and Iceland and other places that have had caldera collapses, like
other volcanoes around the world.
Yeah.
So that's a little window into the research that's ongoing, right? Is there anything in particular that piques your interest, Dane, or you want to comment on?
We do the Iceland thing. We should try and get what was it, Evgenia Iliansky? Try and get her to come back on, because she was, amazing at the Iceland volcanoes. Her knowledge in that, and her specialty was particulate matter, especially heavy metals from the plume in the eruption. So it would be, it'd be a great time to try and see if she want to get back on.
Yeah, we'll see if we can get her and any other special guests for you guys as well. We'll see what we can line up here.
Right.
Some of these more interesting studies. So, any other
and
questions?
Now everybody's right now. Everybody's getting better at Zoom, so it isn't so much of a foreign concept to tell somebody like, okay, we're gonna VoIP you in, and they're like, wait, what? What is VoIP? What it's like, oh, we're gonna Zoom you in, and they're like, oh, okay, I know what you're talking about now. Okay.
Yeah. So, any more questions we want to take before we wrap it up here?
Last one. The only one I see is about Mauna Loa. When was the last eruption? 1984. Small one. Went towards Hilo. Lasted a little while.
Yeah.
Didn't have the volume to get down to the town or get really, really close to it. But yeah, went that direction.
Yeah, it was a little over 2 weeks. Yeah, and it was actually pretty good volume for it to have reached that far. It's a big mountain.
2 weeks, yeah.
But it's a long way. It's a long way. So it wasn't enough to get all the way. Yeah. Yeah, that was the last kind of, that eruption that actually was concerning. There was an eruption in 1975 before that. That might have been a day at the summit. Right?
Yeah, somewhere around there. Yeah.
Before that, it might have been 1950, might have been the last one, really. So it's been, and that was really the biggest devastating eruption was 1950. Right? That was the last one that really wreaked havoc on an island. More so than 84. In 84, they were going to consider evacuating Hilo, and they never quite came to that, but they were days away. So, and
it was slow. It was at the end. It was getting slow because it hit the flat points of the mountain. It was just kind of cruising along. It takes a while to get down there, like the one 1880 to 1881 eruption.
Right.
I think it took 340 days or something like that. It was a long eruption to be able to reach into Hilo town to finally get in there.
Right.
But yeah, it can reach Hilo. It can reach Hilo. It just hasn't done it recently.
Yep. If it's on an island, it's got there from lava flow, right? So Hilo certainly is built on the delta of Mauna Loa.
Right.
So
how close is the intrusion to the lake? For the last question.
Okay, so let's see if if they actually say here how deep this this thing actually was.
Yeah, I don't remember that.
I don't know if they specify the actual depth of that intrusion, so it didn't really say. Yeah.
Right.
However, the earthquakes were not super shallow, right?
1 kilometer, 2 kilometers.
Right, 1 or 2 kilometers. Yeah, so that would be our best guess estimate. Yeah,
somewhere in there.
Would be that, yeah. So half mile-ish, something like that, yeah.
Below sea level.
Yeah. So,
I think that about sums it up.
Yeah, so
get out of here just a little bit over 1 hour.
Yeah, thank you guys for joining us here. Yeah, just kind of review here the last thing. Here's that kind of key plot we want to show you guys today. The intrusion under Hale Mau. Right there, where sort of green rectangle is right in here. Right, that was the news causing a GPS and a tilt offsets that we saw in these areas over here. So confirmed by USGS. So thanks to USGS for all their data once again, and I do see someone talking about USGS updates. They do update Mauna Loa every week, since Mauna Loa is at yellow right now, right? And they're putting out photos and images and all kinds of good stuff. So check out the HVA website if you guys want to get information more often than once a week from us. All right.
All right.
Thank you, guys. Thanks, Dane.
All right. Thanks, Phil. Till next week. Aloha.